Okay, for today's activity, we're going to be creating a model of DNA. Here we can see a picture of DNA. We've got a couple different molecules that make up DNA. We've got some phosphates and some sugars, okay, which are going to be represented today by two different colors. The colors that I'm going to use for this particular time are going to be orange and green, which are the outside of our DNA molecule or of our DNA. And then the inside, which is the cytosine and the guanine, and the adenine and the thymine, are going to be two different colors. So our adenine and our thymine are going to be two colors, which I give you. In this case, I'm going to use purple and blue. And then for our cytosine and our guanine, I'm going to use pink and yellow. Now, you might get different combinations from your teacher, but in this case, you're going to use these two types of colors for this particular activity if you've got these colors. So the first thing I'm going to do is I'm going to twist our sugar molecules together. So you're going to take your sugar molecules, your two colors, you should have four of them all together, two of the same color of each, and we're going to twist these together. Now, you want to make sure that the ends are twisted together really well so that they don't come apart. And then you should have two of these when you're finished. So here's one, and now I'm going to twist the other one. So now I have my two sugar and my phosphate ready for my DNA, and I'm ready for the next step. The next thing I'm going to do is get out my adenine, thymine, cytosine, and guanine. Now, when you're doing this next step, you want to remember to measure twice, cut once. You don't want to mess up and have to do this over again. So the first thing I'm going to do is I need 5 equal pieces of each. So I'm going to cut one piece. I'm going to kind of measure it out so that it's equal. And then I'm going to measure out 5 pieces. I did a little bending to kind of try to figure it out. The best way to do this is kind of like to make an M. And then after that, make sure that your last piece is kind of equal. Well, I don't want to have to do that for both pieces because then I'm going to be guessing. So what I'm going to do is I'm going to measure this out, but then I'm going to just cut one piece so I can use that to measure from. All right, I'm going to take that one piece, my measuring piece. Looks like that's about equal. And I'm going to cut that one with my scissors. And now I can use that to measure out to make sure that all the rest of these are equal. Looks about the same. And I'm going to cut that one. Now I'm going to do that for both this piece and all my blue pieces. I'm going to make sure to use the same piece each time to measure. So that way I'm getting the same length of pieces all the way through. I want to make sure that no matter what, my pieces end up all the same size. That's super important to creating your double helix. Make sure you have good sharp scissors when you do this. So now I measured out for my thymine. Now I'm going to do the same thing, and I'm going to use it to cut my adenine. Measure it out so that they're the same size. All right, you'll now see that I've got 5 equal pieces of each. Notice that the colors can be on either side. They can match up either way because as long as they're complementary, meaning that the adenine always goes with the thymine, you're good. So it doesn't have to be like blue on one side, purple on the other side. You can match them up either way for your DNA. Now I'm going to twist them just a little bit in the center. I want to try to do that the same for each one to represent the bonds for my DNA. The next thing I'm going to do is I'm going to add just a little bit of tape to the center to make sure that this doesn't come apart in the center. Now I'm going to take and I'm going to just do a very tiny amount of tape around the middle here for each one so that they don't come apart. Now I need to do the same for both my cytosine and my guanine that I'm going to have in my model.